Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.2, Problem 1. This is Section 11.2, Problem number 1. It says, consider the function f of x equals 3x plus 5 over x minus 2. Part A says, is f of x continuous when x equals 2? And then there's a part B, is f of x continuous when x equals 0? So for both part A and part B, we have to answer the three questions about whether or not a function is continuous. So first, with part A, is the function continuous when x equals 2? So the first question you have to ask is, does f of 2 exist? Can I use a 2 as an input and get an answer? Well, let's try it. If I put in a 2, I'm going to have 3 times x becomes 3 times 2 plus 5 over x minus 2 is 2 minus 2. The denominator is 0. So the answer to question number 1 is no. F of 2 does not exist. Now, even though we could find the value of the limit, because I have a no on the first question, I can just stop, and it is not continuous at x equals 2. So part A, the answer is not continuous. Part B, is f of x continuous when x equals 0? So first, does f of 0 exist? So can I put in a 0 for x? So let's do f of 0 equals 3 times x becomes 3 times 0 plus 5 over x minus 2, so 0 minus 2. So if you do the math, you get 5 over negative 2, which is negative 2.5 if you prefer that. So the answer is yes. Does f of 0 exist? Yes, it does. So part 2, the second question, does the limit as x approaches 0 for the function exist? And since we didn't have to do any factoring and we can plug in the 0, we can see that the limit does exist. It would also be negative 2. So the limit of f of x as x approaches 0 equals negative 2.5. And part 3, does the value of f of 0 equal the limit as x approaches 0? And the answer is yes, they're both 2.5. 2.5 for the value of the function, which is equal to 2.5 for the limit. So the answer to that is yes. So the function is continuous at x equals 0. It was not continuous at x equals 2.